Okay, so next up we're going to talk about O3 Mini. O3 Mini is a thing that we're really, really excited about, and Hongyu, who trained the model, will come out and join us.
Hey, how are you?
Hey.
Hi everyone, I'm Hongyu Ren. I'm an OpenAI researcher working on reasoning. So this September, we released O1 Mini, which is an efficient reasoning model in the O1 family that's really capable of math and coding, probably among the best in the world, given the low cost. So now, together with O3, I'm very happy to tell you more about O3 Mini, which is a brand new model in the O3 family that truly defines a new cost-efficient reasoning frontier.
It's incredible.
Yeah, though it's not available to our users today, we are opening access to the model to our safety and security researchers to test the model out. With the release of adaptive thinking time in the API a couple of days ago, for O3 Mini, we'll support 3 different options: low, medium, and high reasoning effort. So the users can freely adjust the thinking time based on their different use cases. So for example, for some, we may want the model to think longer for more complicated problems and think shorter with simpler ones. With that, I'm happy to show the first set of evals of O3 Mini. So on the left-hand side, we show the coding evals. So it's like code versus ELO, which measures how good a programmer is, and the higher is better. So as we can see on the plot, with more thinking time, O3 Mini is able to have increasing ELO, outperforming O1 Mini. And with median thinking time, it's able to measure even better than O1.
Yeah, so it's for an order of magnitude more speed and cost, we can deliver the same code performance on this eval,
or even better experience, right? So although it's the O3 Mini High is still a couple hundred points away from Mark, it's not far. It's better than me, probably.
But just an incredible sort of cost to performance gain over what we've been able to offer with O1, and we think people will really love this.
Yeah, I hope so. So on the right-hand plot, we show the estimated cost versus code versus ELO trade-off. So it's pretty clear that O3 Mini defines a new cost-efficient reasoning frontier on coding. So it's achieved better performance, compared with better performance than O1 with a fraction of cost.
Amazing.
With that being said, I would like to do a live demo
That sounds great.
on O3 Mini. And hopefully you can test out all the 3 different low, medium, high thinking time of the model. So let me paste the prompt. So I'm testing out O3 Mini High first. And the task is that I'm asking the model to use Python to implement a code generator and executor. So if I launch this, run this Python script, it will launch a server locally with a UI that contains a text box. And then we can make coding requests in a text box. It will send the request to call O3 Mini API, and O3 Mini API will solve the task and return a piece of code, and it will then save the code locally on my desktop, and then open a terminal to execute the code automatically. So it's a
pretty complicated
task, right? And it outputs a big chunk of code. So if we copy the code and paste it to our server, and then we would like to launch this server.
So we should get a text box when you're launching it.
Yeah.
Okay, great. Oh yeah,
I hope so.
Yeah.
It seems to be launching something.
Okay.
Oh, great. We have a UI where we can enter some coding prompts. Let's try out a simple one, like print OpenAI and a random number. Submit. So it's sending the request to O3 Mini Medium, so it should be pretty fast, right? So on this
41.
terminal, 41. That's the magic number, right? So it saves the generated code to this local script on the desktop and then print out OpenAI 41. Is there any other tasks you guys want to test it out?
I wonder if you could get it to get its own GPQA numbers.
That's a great answer, just as what I expected. We practiced a lot yesterday.
Yeah.
Okay, so now let me copy the code. And send it in the code UI. So in this task, we asked the model to evaluate O3 mini with the low reasoning effort on this hard GPQA dataset. And the model needs to first download the raw file from this URL, and then it needs to basically figure out which part is a question, which part is the answer, or which part is the options, right? And then formulate all the questions, and then ask the model to answer it, and then parse the result, and then to grade it.
That's actually blazingly fast.
Yeah, and it's actually really fast because it's calling the O3 mini with low reasoning effort. Yeah, let's see how it goes.
I guess 2 tasks are really hard here.
Yeah, the long tail is often the problem.
Go.
Yeah, GPQA is a hard data set.
Yes.
Yeah, it contains like maybe 196 easy problems and 2 really hard problems.
While we're waiting for this, do you want to show what the request was again?
Oh, it actually returns the results. It's 61.62%, right?
Amazing.
62%, right?
Cool.
With a low reasoning effort model, and it's actually pretty fast. Then full evaluation in a minute.
Somehow very cool to just ask a model to evaluate itself like
Yeah,
this.
exactly, right? And if we just summarize what we just did, we asked the model to write a script to evaluate itself on this hard GPQA data set from a UI, right? From this code generator and executor created by the model itself in the first place.
Next year, we're going to bring you on, and you're going to have to ask the model to improve itself.
Yeah, let's definitely ask the model to improve it next time.
Maybe not.
Besides code forces and GPQA, the model is also a pretty good math model. So we show on this plot with on this AMI 2024 dataset, O3 mini low achieves comparable performance with O1 mini, and O3 mini medium achieves comparable better performance than O1 if we check the solid bar, which are past the ones. And we can further push the performance with O3 mini high, right? And on the right-hand side plot, when we measure the latency on this anonymized O1 preview traffic, we show that O3 mini low drastically reduced the latency of O1 mini, right? Almost achieving comparable latency with GPT-4o. Where it's under a second, so probably it's instant response. And O3 mini medium is half the latency of O1.
Got it.
And here's another set of evals that I'm even more excited to show you guys is API features, right? We get a lot of requests from our developer communities to support function calling, structured outputs, developer messages on O mini series models. And here, O3 mini will support all these features, same as O1. And notably, it achieves comparable better performance than 4o on most of the evals, providing a more cost-effective solution to our developers.
Cool.
And if we actually unveil the true GPQA diamond performance that I ran a couple of days ago, it actually also means though is actually 62%, right? We basically ask the model to evaluate itself.
Yeah.
Right. Next time we should totally just ask the model to automatically do the evaluation instead of us doing it. Yeah. So with that, that's it for O3 mini, and I hope our user can have a much better user experience early next year.
Fantastic work.
Yeah. Thank you so
really
much.
great work on you.
Thank you.
Cool. So I know you're excited to get this in your own hands, and we're working very hard to post-train this model to do some safety interventions on top of the model, and we're doing a lot of internal safety testing right now. But something new we're doing this time is we're also opening up this model to external safety testing, starting today with O3 mini, and also eventually with O3. So how do you get early access as a safety researcher or a security researcher? You can go to our website, and you can see a form like this one that you see on the screen. And applications for this form are rolling. They'll close on January 10th. And we really invite you to apply. We're excited to see what kind of things that you can explore with this and what kind of jailbreaks and other things you discover. Cool.
Great.
So one other thing that I'm excited to talk about is a new report that we published, I think yesterday or today, that advances our safety program. And this is a new technique called deliberative alignment. Typically, when we do safety training on top of our models, we're trying to learn this decision boundary of what's safe and what's unsafe, right? And usually it's just through showing examples, pure examples of this is a safe prompt, this is an unsafe prompt. But we can now leverage the reasoning capabilities that we have from our models to find a more accurate safety boundary here. And this technique, called deliberative alignment, allows us to take a safety spec, allows the model to reason over a prompt, and also just tell, is this a safe prompt or not? Oftentimes within the reasoning, it will just uncover that, hey, this user is trying to trick me, or they're expressing this kind of intent that's hidden. So even if you kind of try to cipher your prompts, oftentimes the reasoning will break that. And the primary result you see is in this figure that's shown over here. We have our performance on a rejection benchmark on the x-axis and on over-refusals on the y-axis. And here to the right is better. So this is our ability to accurately tell when we should reject something, also our ability to tell when we should refuse something. And typically you think of these two metrics as having some sort of trade-off.
It's really hard to do well on both at the same time.
It is really hard to do, yeah. But it seems with deliberative alignment that we can get these two green points on the top right, whereas the previous models, the red and blue points, signify the performance of our previous models. So we're really starting to leverage safety to leverage reasoning to get better safety.
Yeah, I think this is a really great result of safety.
Yeah. Fantastic.
Okay, so to sum this up, O3 Mini and O3, apply please if you'd like for safety testing to help us test these models as an additional step. We plan to launch O3 Mini around the end of January and full O3 shortly after that. But that will, the more people can help us safety test, the more we can make sure we hit that. So please check it out. And thanks for following along with us with this. It's been a lot of fun for us. We hope you've enjoyed it too.